Alright, so in this video we're going to talk about how to graph quadratic equations. If you've seen in the writing video, you've seen that there are kind of three forms, and I kind of talked a little bit about what those forms kind of tell you. So we're going to kind of look at some examples today and kind of see what form it's in and how can I kind of graph it. Okay? Now one thing you can always do when you graph is you can always plot points. Okay? But as a lot of you saw when you did the representation matching, if you don't actually know what the shape of the equation is, okay, you're not going to get the right graph. Okay? So first off, you kind of got to know what a parabola looks like. It's kind of the U-shaped, open up or open down. So one of the key things you're going to see in this video is you have to find the vertex. You have to find where the graph turns and comes back down, or when you're going down, turns and comes back up. If you can't find the vertex, you can't graph a quadratic. So we're going to really kind of focus in on how do I find the vertex depending on how the problem is given to me. Alright, so first one we're going to look at is y equals 2 x minus 3 squared plus 1. Okay? This is what we call vertex form or our transformation form. Okay? You can see in here you've got this x minus 3. Okay, so when we've seen something with an x minus 3, well, that's going to tell us that that thing's going to go to the right 3. We see this 2 here out in front of kind of the function as a multiplier. That's going to vertically stretch this, so it's going to make the parabola a little bit skinny. Okay? And then adding 1 is going to kind of move it up 1 and shift every point up 1. Okay? So one way we can do this to kind of be consistent with some of our other videos, let's strip away all the transformations. Get rid of the 2. Get rid of the minus 3, get rid of the plus 1, and all you're left with is a very, very simple parent function, y equals x squared. Okay, so when I look at y equals x squared, that's very easy to graph. Think about some data points, -2, -1, 0, 1, 2. Put -2 in, -2 squared is 4. -1 squared, 1, 0 squared, 0. 1, 4. You get a lot of symmetry with parabolas because squaring a positive negative gives you the same answer. Alright, so what I can think about is, okay, what does that graph look like? Well, when I plot it, -2, 4, 1, 2, 3, 4. -1, 1, 0, 0. 1, 1, and 2, 4. So I get this curve called a parabola. Okay. Different from an absolute value. Notice the jumps are different. This was a vertical jump of 3 from 1 to 4, but then I only jumped 1, so it's not a consistent jump, which is why they're not straight lines on each side. Alright, so there's my graph. Well, what I could do now is just apply the transformations that I know. Now we're right back to the first unit in the sheets that we had you do. Okay? When I look at this, I go, okay, what does this do? This stretches, or I'm going to double the y's. Okay? So I'm going to take all my y values and double them. So this becomes 8, 2. Doubling 0 is still 0. Doubling 1, 2. Okay, so that's going to take that graph and kind of stretch it up, make it appear skinnier. Okay, a skinnier parabola. Alright, what else am I doing? We're going to move right 3 and then up 1. So what I could do is I could, maybe draw this second graph and then right 1 and up, right 3 and then up 1. I could just come and change all my kind of, coordinate points. Kind of depends on what how you want to go about, doing it. Okay? So I'm going to do this. I'm just going to graph this guy and then kind of shift the points from there. So -2, 8, that's going to be pulled way up there. 2, 8's pulled up there. -1, 2 is now there. So I'm going to get this kind of, skinnier looking parabola there. And then from there I want to shift it right 3 and, up 1. Okay? So I'm going to take every point and go right 3 with them. So we kind of just get rid of this guy. Rid of the blacks, and I've got the stretched red one, and I'm going to take that and go right 3 and up 1. So right 1, 2, 3, and up 1. Take this guy and go right 3, 1, 2, 3, up 1. Take this guy and go right 1, 2, 3, up 1. Yep. And I can do the same thing with these points here, but I think those 4 points or 3 points are kind of good enough to get the idea. So there's my skinnier parabola, shifted right 3 and up 1. Okay. I also could have just focused solely on these points. Right 3 would have moved these new points all to the right 3, so added 3 to the x's. So negative 2 plus 3 is 1. Negative 1 plus 3 is 2, 3, 4, and 5. And then the y's all went up 1. So this is going to be 9, 3, 1, 3, 9. And so really, what am I plotting? 1 is up at 9. Sure, that makes sense. 2 is up 1, 2, 3. Yep, there's that point. 3 is at 1. 1, 2, 3, up 1. There was that guy. 4 is at 3, 4, then 1, 2, 3. I erased that point, but it would have been there. And then 5 would get me back up to 9. All right, so I could really start with this data table and just do it this size. Move the x's to the right 3. Add 3 to the x's. Okay? Double the y's. 4 to 8, 1 to 2. And then add 1, up to 9, up to 3, up to 1. Okay, so that's really using your transformation. So this is really a transformational graph. Okay, and again, we talked about the vertex. The vertex should be at 3, 1 for that h and k piece. Okay, so vertex is over 3, up 1. Sure enough, there it is. So that's how we kind of graph something when it's given to us in that vertex or transformation form. Kind of strip away all the pieces, look at just the general one, and go from there. The other option is really you could think about your vertex is at 3, 1, plot that point, and then really about making your table, just kind of use data points around 3, plug them in, do the math to get your answers as well. But again, we really want to kind of know what those transformations are and what they are doing to the graph. Alright, so let's look at a second example. Y equals negative 4x squared plus 8x minus 1. This is what's called, standard form. This is probably the most typical form you're going to get the equation in. Okay? So there's a couple of methods, again, ways to do this. First off, I've got to find the vertex. I've got to know where the vertex is. If I don't know when the graph is going to come back, up. Or in this case, since a is negative, I know it's going to be flipped. So I know I'm going to get, a graph that curves and then comes back down. Okay? All right, so what do I do from there? Well, one thing is I could put it in vertex form. So I could complete the square. So I'm going to do that. So I'm going to pull out a negative 4. Now when we think about completing the square, I'm going to keep that minus 1, keep that constant kind of out of the way. So when I divide by negative 4 divided by negative 4 is just the 1x squared. And 8 divided by negative 4 is negative 2x. All right, so now I got to figure out what goes here. And I'm going to kind of keep things on the same side. So I'm going to have to subtract that number. All right, well, we'll see what happens actually. So how do I find this value again? Well, I'm going to take half of the b, so half of negative 2 is negative 1, and square it, so that's 1. So I'm going to get plus 1 there. But as we talked a couple of different times in a couple of different video sets, it's really not a 1 I added, it's negative 4 times 1. So I really added negative 4. And if I'm going to stay on the same side of an equation, if I put a negative 4 in there, then I need a positive 4. So I was actually right initially that would be a plus 4 there, but that's only because this number is actually negative. So I need the positive 4 to cancel it. Those two add to 0. All right, so go from there, negative 4, factor this. This is going to be x minus 1, right? Take half of that squared, and negative 1 plus 4 is plus 3. And there we go. So there's our graph. What's the transformations? Right 1, up 3. Reflected and stretched by a factor of 4. Okay? So let's think about how I could do this again. If I went back to points, negative 2, negative 1, 0, 1, and 2. That was what? 4, 1, 0, 1, and 4. Okay, so those are all my perfect points. Now I can kind of do my transformations on them. going to go right 1, so I'm going to add 1 to every single point. So negative 1, 0, 1, 2, and 3. I'm going to multiply the y's by negative 4 and then add 3 to them. So 4 times negative 4 is negative 16, plus 3 is negative 13. 1 times negative 4 is negative 4. Negative 4 plus 3 is negative 1. 0 times negative 4 is 0, plus 3 is 3. 1 times negative 4 is negative 4, plus 3 is negative 1. I should have some symmetry in this graph. And then negative 4 is negative 16, plus 3 back to negative 13. All right, so from there I can just plot my points. My vertex should be right 1 and up 3. That's going to be where 0, 0 was. So these are all gone in here. So my vertex is at 1, 3. At 0, I'm down at negative 1. And at 2, I'm down at negative 1. There's the symmetry. And then at negative 1, I'm way down here at negative 13. Let's just call it there. And then at 3, I should be at that same height. So we get this super skinny graph. Okay. Kind of almost looks like a V. Got to give a little bit of curve to it. Right, but because of how steep that is, because of that negative 4, really stretch that graph out. Okay? So that's sort of one way to kind of figure it out. Okay? A second way to kind of do the same thing, and we can kind of make some connections here, is, in this form I can find the y-intercept from C. Because when I plug 0 in for x, I get my y-intercept, and sure enough, 0, negative 1 ended up being a point, so that was sort of a nice check for us. Okay? And the last part we want to try to do is, how do I find the x value of the vertex? Well, the x value of the vertex ended up being 1. Okay? And here's how we found it. We pulled out a negative 4, so we took our b value. So remember, this is A, this is B, and that's C. Okay? So what did we do? We factored out a negative 4, which meant we divided B by negative 4. But negative 4 was A. So we took B and divided it by A. And that got us to negative 2. But then to complete the square, we had to take half of that value. Remember, half of this is what goes there. So we're going to take half of this value. Okay, so we're going to take half of negative 2. We're going to take half of this. Well, when you take half of this, you're going to multiply it by 1/2. Okay, so we get B over A times 1/2. So I get B over 2A. Okay? So we're almost there. Okay? But the reality of this is, if this was a minus, it actually was a plus, and vice versa. So what we actually have to do is we're going to actually have to take the opposite of our answer. So it's going to be the opposite of B over 2A. Okay? So let's sort of see how that sort of plays out here. Well, if B was 8, I'd be taking the opposite of 8 divided by 2 times A. So 2 times negative 4, that's negative 8 over negative 8. So the x value of the vertex is in fact 1. Okay? So another way to kind of do this without maybe putting it into vertex form by completing the squares, you could find the x value of the vertex. This is what x is equal to by taking the opposite of b divided by 2a. Now once you know the x, what you'd have to do is you'd have to come back to this original equation, plug in the y, or plug the x in to find the y. Negative 4 times 1 squared is negative 4, plus 8 times 1, so that's negative 4, plus 8 is 4, minus 1 is 3. And sure enough, we got the vertex at 1, 3. And there it is. Okay? So once you kind of plot that point, you could think about, I know the vertex, I know the y-intercept was at negative 1, and then I could kind of reflect that point over what we call our axis or line of symmetry. One away, put it one away, and there's kind of at least 3 nice points to kind of find it. Okay? Or again, you can kind of make a table, plug some points in, and kind of get your answers from there. All right, so one last example. What if I gave you something like y equals x squared minus 4x plus 3? We're going to look at this a couple of ways. I'm not going to complete the square this time. I'm going to actually factor it. I recognize this pretty quickly. We'll factor into x minus 3, x minus 1. So what that tells me then is I have x-intercepts at 3 and 1. So there's 1, there's 3. Right? As I kind of mentioned earlier, that the vertex has to lie right in the middle of these. Okay, so if you've got 2 points at the same height, the vertex is in the middle. So I actually know the vertex is at x equals 2. So the vertex is always going to be right in the middle of your x-intercepts. So the vertex is at p plus q divided by 2, which is the average of your x-intercepts. Okay, but remember, p is 3 and q is 1. Where are the x-intercepts? Remember, always the opposite of the number for x's. All right, so x is 2. I can find the y for my vertex by plugging 2 back in. So y would equal 2 minus 3, 2 minus 1. 2 minus 3 is negative 1 times 1. So y equals negative 1. So I have a vertex at 2 comma negative 1. Right there. Okay. So there's a couple of nice points. In this form, remember the 3 is your y-intercept. So I can plot that guy, 1, 2, 3. And if I thought about this line of symmetry, I actually know another point. It's going to be at the same height and the same distance away. So this point is 1, 2 units away. So if I go 1, 2 units away, I'm going to be at 1, 2, 3, 4. So 4, 3 must be another point. Five points are really nice in order to kind of find where your vertex is. Or, I mean, 5 points is nice to draw a nice parabola. All right, let's just quickly kind of show, since this was in standard form. Remember a minute ago we talked about that the vertex is at the opposite of b over 2a. So the opposite of negative 4 is positive 4. Over 2 times a is 1. So 4 divided by 2 is 2. And sure enough, that's where we found the x value of the vertex to be at. And I could again plug 2 in. So again, I'm showing you lots of options. Y equals 2 squared minus 4 times 2 plus 3. 2 squared is 4 minus 8 plus 3. 4 and 3 are 7. And a negative 8 is negative 1. Sure enough, vertex is at 2, negative 1. And if I decided to complete the square on this guy, I would have y equals x minus 2 squared minus 1. You get kind of the same thing. So lots of different ways to kind of do that. So that's how you graph. Again, rewatch them. Remember, you can pause, ask questions as you go through. Watch it over and over again to kind of see the different ways to graph the 3 different forms that we looked at.